All right, next we're going to study a queue. In America, we call these lines. Everywhere else, they're called queues. So be it. So when you wait in a queue at a bank, and by a queue I mean a line, it's first in, first out. So the first one in the queue or line is the first one out of it. So that's called a FIFO data structure. The key element is that middle elements are inaccessible. Waiting line in a bank. Yeah. Okay, that's nice. You know what? No, we don't have a picture. Okay, what do you want to implement a queue with? So in a stack, you always look at the top, but in a queue, you're going to have, numbers or whatever we want to have. 42, there we go, -3. And the 3 will be the first one to come out of the queue. And then if someone wants to jump in, they have to go to the back of the line.
Let's implement our queue with the stack.
One moment. Yeah, that can be done. Do you really want to do that?
Not really.
Okay. I was going to watch you do it, because it can be done.
It can be done, yeah.
Everything will be O of N operations. Because you got to keep pushing it back and forth.
I was thinking array since we did linked list earlier.
All right, let's do an array. All right, let's do stack, test, move it to test, the Q test. Oh, the cutest. All right. All right, instead of a stack, we want to have a queue. Have a queue, 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 queue.
Such a weird word.
Yeah, there's a lot of those, yeah. Maybe that's why we decided to use the word line instead. Because isn't it spelled Q-U? Q-U-U? Q-U? Whatever. All right. So we do a peak.
That was recorded, right?
Oh, yeah. Yep, still going. So in this queue, what's the first element? Yes, 1, 2, 3, 4. Does 5 come next?
Yeah.
Then what comes last?
42.
All right. I'm so tempted to implement it with a stack just to be that way, but no. No, we're not going to do that. All right. Actually, let's just copy it over. Yeah, just so I can prove or drive the point home. Oops, that's not what I'm going to do. Stack.cpp. I'll copy it over to queue.cpp. Nope, that's not what we want. Do we fill our queue? Whoa, we got all sorts of problems. Oh. Whatever. There, and we failed. Great. And what did we fail? Line 19. Yep, good. So we're failing this one, probably because we're using the linked list code, so let's just get rid of that. Okay, so we're not using a linked list. Do it. How many elements are you giving it? Or are you going to make this a... Ooh. Does C++ allow you to do that? I don't think C++ can allow you to dynamically extend a struct. Int star is fine. Semicolon. Oh, you already have the star. Oh, 100 pointers? Oh, okay, delete it. Okay. Don't forget the semicolon. All right. Okay. So we have an array of 100 elements. Great. Do we need anything else? Probably 9. Yeah. I mean, we can start. Yep. Maybe we should look at the functions first. So how would we push a value? Ooh, let's go up here and get rid of this head equals null.
Stack size. No, this is different.
What does the queue have? Well, stack, you really just had to keep track of the head. What do you got to keep track of now?
The last one.
Oh, yeah. All right, I'm going to move this along just a bit. All right, there we go. This is not necessarily the best way to do it. I'm just giving you something to start with. We'll have the head and tail be at 0 because there's nothing in the queue, right? Right. Yeah. All right. Raise tail equals. Oh. Tail. Yeah. Okay. Well, then in peak, what are we returning?
The first value, so head.
Okay. Let's see if how far that gets us. Oh, line 21, so we failed at a different spot. So we failed here, probably because pop is not implemented. What do we do here? Well, what do we need? Well, okay, sorry, keep going. What are you trying to do, or what are you thinking?
Copy everything down one,
Oh, okay.
and then reduce the tail.
That would work. Anyone think of a simpler thing to do? I'm not saying that's bad, because it actually avoids a different problem.
Because the only other thing I can think of is increasing head.
Yeah, let's just increase head. Do that. Head plus plus.
You guys see the problem?
The thing is, though.
I mean, moving everything down did solve one problem. Hey, we passed. But what's the problem here? Excuse me.
There's
Not good.
still going to be memory in the first thing of the array.
Right, so I'm going to do void test. I'm going to just call it sadness. Sadness. Here we go. So let's do, oh great, Q for int I equals 0, I plus, then we'll do 75, I plus plus, Q push I, Q pop. And then we should have, was it test assert q dot peak equals I, and then all right. So I push a bunch of elements, I pop them. Now I'm gonna push 75 afterwards. Yeah, let's see what happens. Actually, this might still pass. No, it failed. Line 40. Line 40 failed? Oh, right here. Huh. Wonder why that failed.
Or were you expecting it to fail?
I wasn't actually expecting it to fail. Push I, we peak, and we pop. Oh, I wonder why that failed. Oh, well, anyways. Okay, so what's the problem here? Well, if you keep moving the queue down the array, what happens when you get to the end of the queue?
Not going to have the room.
Right, you're not going to have the room, so we're not doing any checking to see if it's full here, are we? No. No. Let me see if I can print this out. If tail is greater than or equal to 100, I'll do std cout. Q is full, head equals and we'll need to include IOStream. Q is fuel, head is 75, head is 25. How did head become 25? What happened here? Now something else is going on. I'm kind of confused. Let's see what tail is. Oh, and then it's circle. Why did head become 25? Huh. Oh. Yes. That makes sense. Okay. Because it's overriding it. Oh, you're having huge memory errors. That's the problem. So, if the queue is full, what's going on over here? Is this a legal memory write or read? If
I mean,
tail,
we can do it, but it's not going to do very well.
right, so I'm just going to go return right here. That way we don't have problems, and then we'll do make Q. There we go. Head is full. There we are. Head 75, tail's 100, and then it fails, and that makes more sense because we can't put anything more in the queue. Yet, if head is 75, that means the front part of the queue has 75 elements that we could be using, but we're not. So how could we solve this problem?
By copying the array over to another array?
I mean, sure, we can make a new array, but do we need to make a new array?
We can just shift it down.
We can just shift it down. Okay. Go for it. This will make it, yeah, I like this. Oh. Well. I think you want I to start ahead. Probably want ARY sub I minus head. So that's 0. Yep. And what should that be set to? All right. I think that will solve this problem. We just need to not return. Oh, yeah, we forgot to do one other thing. So you copied it all down. That's great. Probably should update head and tail now. Update tail first, because you need head in order to update it. Well, not if, right. Go ahead. So the head was 75 and tail was at 100, so that means there's only 25 elements. In this case, it would make tail 75, which is not what we want. How can we get that 25?
100 minus that? Yeah.
Or what's 100 at that moment?
Tail.
Tail, yep. There we are. And then let's not return, and that should do it. Hey, it worked. And you only had to move it down once. Okay. Well, what does that unfortunately do with our worst case scenario for push?
It makes it O of n.
O of n. Is there any way we could fix that?
I could do what I was gonna do earlier.
Well, then that makes pop O of n. All right, here we go. Q operation has arrays, so we start, they called it rear and front, we called it head and tail. There's A, B, C, and then when you want to pop, you simply move Q front from 0 to 1. That looks great. Will this design work? Well, we have the AAD, dad, okay. Until something up here, Q front 97, 99. That was like our example where we had head at 75, tail at 100. What will we do? Well, the solution we came up with was shift everything down. There is another solution. All right, when overflows, points to last array, check for front. If it indicates there's room in the front, slide all the elements down. Too slow for large Qs, that's what we did. Solution 2, assume the array is circular.
What? It's a circle now?
Yes. Assume the array is circular. And I have been tempted so many times to make y'all implement this. I'm not quite that mean. All right, circular Q. Your array looks like that. Everyone got it? It's a circle. How does this work? Well, your Q front might be 99, Q rear is 90. You add an element. Since Q front or head is 98, you can just put it over to 0, so your rear is now 0. Everyone got that?
Yeah.
All right.
I mean, I've got it, but
Can anyone see a problem that's about ready to occur?
if it goes too large, you have no real way of fixing it.
Okay, yeah, if the queue fills up, you still have to allocate a new queue and put the buffer in, yes. It does not eliminate that problem. But there's another problem that's about ready to happen. How do you tell when the queue is full? Well, beforehand we checked if queue front and queue rear were the same. Well, oh, actually, they're going to show you deletion case problem. Here we go. Q front's 98, the rear is 98. If you delete something, the front is 99, the rear is 90. Okay, that's actually fine. Let's see. So before the that's actually fine too. Oh, no, it's not. So here we go. If you have, let's see, what is this a picture of? Q elements, you know, the front's 99 and goes all the way up to 97, and then you add Z, the Q front starts at 99, goes all the way back to 98. But over here, you deleted this X, Q front became 99, Q rear became 98. In this situation, the Q is empty, and it has 99 for the front and 98 for the back. In this situation, the Q is full and has 99 for the head and 98 for the tail, or the rear. But they're two separate situations. In this case, it's full. In this case, it's empty. So how do we tell? Do y'all see the problem? No? The problem is an empty Q has the same values for front and tail as a full Q has for front and tail when they're circular. Namely, if you have one element left, the Q front's 98, the tail is, is also 98, so they're both here. And then you add the head will be incremented to 99, the rear is at 98, to signify that there's nothing left because the Q is empty. In this implementation, they had the head or the tail be one less than the head, which is annoying, but oh well. And in this situation where it was almost full, the Q starts at 99, wraps around all the way up to 97. You want to add Z to it, so Q rear is 97 because it points here, and the rear is pointing to the last element, aka so you need to add after it. In this situation, the Z comes after at 98. Now you have the tail or the rear at 98 and the head or the front at 99, which is the same as the situation for this empty Q that we got to by deleting the X. So both of these have the same values for head and tail, yet in one of them the Q is full and the other one the Q is empty. we need to know the queue is empty, because if we want to add an element to an empty queue, we should be able to do that. How do we fix this problem? Anyone? Anyone? What additional information could we store?
How many
Elements
indexes are full?
Yeah, how many elements are in the queue? Yeah, right. So in this situation, the number of elements would be 0. In this situation, the number of elements would be greater than 0. So then you could tell which situation you were by checking that variable. Solution, keep a count. Sure. All right, that sounds great. So now that we've talked about how to implement a queue with an array, let's talk about doing it with a linked list. Or maybe not. There we go. Which may be really short.